So in this part, I'll walk you through how to name inorganic compounds. To start, there are two types of inorganic compounds. The first type is inorganic compounds, which are made up of two atoms. This is called a binary compound. So it's just like you look and see, it's like two different types of atoms in there. And then you have a polyatomic compound. This is made up of more than one atom. So let's consider the first case, which is the case of metals and nonmetals. So all of these examples that you see, these are considered to be binary compounds. These are made up of two atoms, two types. Let's say two types of atoms. So it's made up here of magnesium and fluorine. Although fluorine is two, but it's made up of magnesium and the fluorine. This is two different types of atoms. Same thing for each one of those. It's made up of two different types of atoms. So we are talking about this kind over here, which is the binary compound. There are multiple cases. So let's start with the first case. Case of a metal and a non-metal. So your periodic table has to be with you just to know what type of atom are you working with. It's a metal or a non-metal. With these types, you always start with the metal and you name the metal first, and then you name the non-metal as a stem and you add an IDE. This case is between groups 1, 2, and 3, and groups 5, 6, and 7. Okay, so let's have an example. And notice here, every time I write the molecular formula for these molecules, I always start with the positive part and then the negative part. So it's the metal and then the non-metal. So I have sodium. Sodium is in a group 1, and the chlorine is in a group number 7. So this is the case of a metal and the non-metal. 1, 7. So 1, 7 in there. This is the rule that I need to follow. First, I'm going to name the metal, and the metal here is named sodium. Please have your periodic table next to you, the one that has the names of all of these atoms. So that is going to be sodium. Now, this one is a chlorine, so what I would do is I would name it as a stem. So it's going to be chlor and then add an ID at the end. So it's going to be chloride. So the ending is IDE. When you look at the name and you see that the ending is IDE in there, this means that the non-metal is considered to be a simple atom. It's a simple atom in there, like chlorine, like fluorine. There is no other atom next to the to this atom, or no different atom next to this atom. Okay, so this is what an IDE means. An IDE means a simple, like one type of a nonmetal, which is here, it's going to be a chloride. If I want to name this is going to be magnesium. So I always start with the metal, so it's going to be magnesium. And pay attention to your spelling. So it's going to be magnesium, IUM, and then it's going to be fluoride. Fluoride, FLUORIDE. Okay. This one is calcium, calcium, and then this is a nitrogen. It's a one element, right? So it's going to be a nitride, ending in IDE. This one is going to be SR is strontium. It's going to be strontium, and SE is selenium. So I'm just gonna end it with IDE. So it's going to be a selenide. Okay. Um, This one is going to be aluminum, and oxygen, we call it oxide. Aluminum, just get used to these names. Oxygen, we call it oxide. This one is going to be aluminum, and the chloride. There is no I over here. It's just U. My bad. And there is no I over here. It's just U. So aluminum. Uh, okay, and then the chloride. So all the ending is going to be an IDE whenever the non-metal is just one type, okay? One type of atom. So here it's a sulfur, right? So it's going to be sulfide. So it's going to be sodium sulfide, okay? Um, So what is the type of the bonds for each one of these? Of course, this is a metal and a non-metal. So it is an ionic bond. This is an ionic bond. This is the type of the bond in all of the molecules. It is an ionic bond. Okay? In this case. Now, if the metal or the non-metal is a polyatom, there is a table over here. This is table 4.7 for the polyatoms. And there is another table for the polyatoms as well. This is the table, and I am posting it as well to eCampus. So this over here is table 5.3, and this is another table for the polyatoms. Okay, whatever you don't find in the table in the notes for the polyatoms, you can find its name over here. Guys, you are not responsible to memorize any of those names. You will have these tables in the exam. So you just look for the polyatom and you know what, you just refer to its name and you write it down. Okay, so this is the table of most of the polyatoms in there. So what is a polyatom? A polyatom is see, it is the second part of the molecule in here, which is the non-metal part. So the non-metal part is made up of more than one atom. Okay, it's either the metal part or the non-metal part, it doesn't matter. So if you have one part of the molecule that is made up of more than one atom, then this is called a polyatom case. The polyatom is not just in the non-metal part, it can be also in the metal part. I'll give an example on that. So over here I see that I have a case of a metal, which is sodium, so I just name it as a sodium. And then look for the name of the polyatom in the table, and just write it down. So SO4 in the table is called sulfate. So I'm just going to write it as a sulfate in there. See, the ending is no longer an IDE because you can see that the non-metal part is made up of more than one atom. It is a polyatom. So this is why it has to end in the name of that polyatom. Same thing here. This is sodium. And then the OH, so if you look at the OH, where's the OH? It's here. So the OH is named hydroxide, so you just write it as a hydroxide. You continue the rest. Calcium, the CO3 is carbonate, so that one is calcium carbonate. Okay, calcium is IUM. This one is sodium, and again, this one is made up of chlorine and an oxygen, ClO3. So you look here, the ClO3 is, let's see, it is chlorate, and it is found in the second table here. So where is that? This is the ClO4, this is perchlorate, ClO3. So this one is going to be chlorate. So whatever you don't find in that table, you're going to find it in this one. So this one is going to be chlorate. Okay, it's not necessary that the polyatom is in the second part of the molecule. No, it can be in the first part of the molecule. How do you know? Because you know that the chlorine is negative, right? So definitely it needs to be balanced with the whole thing here, which is positive. So the NH4 here has to be positive, and I know that this one here, since I have a plus minus, it is going to be an ionic bond between the nitrogen and the chlorine. So when I want to represent this, it's going to be a nitrogen with 4 hydrogens there. The nitrogen will be a positive charge, and that will be balanced by the Cl, which is going to be negative. The interaction between the chlorine and the nitrogen is an ionic interaction. So you have an ionic bond between the nitrogen and the Cl, but between the nitrogen and all the hydrogens, this is a covalent bond. Okay? So in this case, I need to start by naming the polyatom positive part first. The NH4 is called ammonium. So the NH4 is called ammonium. It's here. This is the only positive polyatom that we are going to consider. We're not going to consider any other positive polyatoms. But as you can see, you have a lot of negative polyatoms there. So that one is going to be ammonium. Okay, and then it's going to be chloride. Notice why I'm back to the IDE, because my nonmetal is just one type of atom, okay, or one type of element. Over here I do have aluminum. So aluminum is the metal. You have to differentiate, and you have to know where is your metal part, where is the metal part ends, and where is the non-metal part begins. So the metal part is the aluminum. Now we don't have a non-metal part, we have a polyatom. So the polyatom is made up of PO4, and the PO4 is a phosphate in there. It's called phosphate. Notice the charges of all of these polyatoms. So that is going to be aluminum phosphate. Okay. Same thing. This is the positive part, which is the sodium. Look at the table for the NO3, and the NO3 is the nitrate. So that is going to be nitrate. You guys, when you are looking at these polyatoms, there are ones that are they are belonging to the same family, like NO3 minus, NO2 minus. You can see that the difference between those two is the one oxygen less. So the ATE represents basically an additional oxygen. So whenever I say ATE at the end, this means that it has more oxygens than the ITE. ITE represents lower number of oxygens. Same thing when I say, for example, let's say sulfate. Let's use another color. Same thing when I say the sulfate and the sulfite. So the sulfate is SO4, more oxygens. The sulfite is SO3, less oxygens. Okay. Let's continue. Okay, so let's say, for example, now if I go and I give you the name, and I ask you, go ahead and draw the formula of the compound. So before we had the formula and we are naming it. Now it's the opposite. I give you the name and I want you to draw the formula. So you want to make sure to draw the right number of atoms in the formula. So you have to pay attention for the charges. You know that all of these are ionic, right? These are all ionic bonds. So you have to pay attention in there. So now you need to have your, again, periodic table next to you to know what the groups are these metals in. So you go with magnesium, always start with the metal first. Metal is always first. So magnesium in there. So I know that magnesium is in a group number 2. So I'm just going to go ahead and draw a +2 in there. I need to draw the charges because I need to balance the charges to get the formula for the molecule. And then the nitride in there. I know that the ending is IDE, so it's just the nitrogen. And I know that nitrogen is in what group? It's in a group number 3, so it's going to be a 3 minus in there, right? Okay, so now I need to balance the charges. Remember what we did last time to balance the charges? Just cross the charges, crisscross those charges in there, okay? So the 2 now is going to go towards the nitrogen. The 3 is going to belong to the magnesium. And we're going to go ahead and write down the formula for the compound, which is going to be Mg. It's going to be 3 and N2. Let's check the charges. Let's check the charges to make sure that everything is balanced. I know that Mg is a +2. I know that magnesium is -3. So this is a +6 -6. See? +6 -6 is a 0. And this is what we need. We need that my final charge has to be 0. We can erase those. And this is going to be the formula. for magnesium nitride. Let's try another example. Beryllium sulfide. So again, IDE, it means that it ends just in sulfur. Beryllium is in the group number 2, so this is 2 plus. And sulfur is a non-metal that is in the group number 6. Group number 6 should gain 2 electrons as well. Whenever you have the charges are the same, see, plus 2 minus 2 in there, you don't have to cross anything. Those two are already balanced. So your formula is going to be a Be and an S. Aluminum and bromide, you guys, same thing. Bromine is just one atom. So I'm just going to have aluminum and I'm going to have the bromine. Now I'm going to put the charges. Aluminum is plus 3. The bromine is a negative 1. The charges are not balanced. So I'm just going to go ahead and crisscross those. And it's going to be an Al. It's going to be 1 because the charge of the bromine is 1. It goes to the aluminum. And the charge of the aluminum is 3. It goes to the bromine. So it's going to be a Br and a 3. Double check. The Al is a 3 plus, not 2 plus, a 3 plus. And the Br is negative. So 3 plus the 3 minus, they balance each other. Okay, let's take out the charges in there. And this is the formula. The formula is without the charges. You don't have to show any charges in there, but you have to show the right number of atoms for the metal and for the non-metal. Okay. Potassium oxide, again, oxide is an oxygen. It's just an oxygen because it ends in IDE. So every non-metal part that ends in IDE, it means that it is one atom in there, or it's just one type. I mean, one type of atom. It's not necessary. It is just one, but it is one type. Okay. So potassium oxide. This is K and this is O. The K is plus 1 and the O is negative 2. Cross the charges and that is going to be K2O. Now, let's have examples on polyatoms. So see, the ending is ATE now. This is a polyatom. And ammonium is a polyatom as well. I go to the table in there. And this is going to be my positive part. Ammonium is this, so I just draw it as I see it. So this is going to be NH4. In the table, the NH4 is positive. Write down the positive sign because I want to go ahead and make sure to balance the charges. Phosphate. Phosphate in the table is PO4 3 minus. So that is PO4. And that is a 3 minus in there. So the whole thing, this whole phosphate, you can put it in parentheses. It's fine. Just to say, okay, this because it's made up of multiple atoms in there. So this whole thing has a 3 minus in there. And this one is a plus. The charges are not balanced. So I'm just going to go ahead and crisscross those charges. So my formula is going to be NH4. The 3 is going to belong to all the NH4s. Whenever I have more than one atom, you guys, whether it is in the metal part or the non-metal part, please put parentheses like I did, so that to show that this coefficient 3 belongs to every single atom in the ammonium. So it does belong to the hydrogen, it does belong to the nitrogen. So if I'm reading this, I have 3 atoms of nitrogen and 12 atoms of hydrogen. Okay. And then I have the PO4. That's it. This is a plus 1, so here this one is going to be a plus 1. No need for parentheses because there is no coefficient for the PO4 in there. If we want to go ahead and check the charges, ammonium is a plus, so that's going to be 3 plus, and that is balanced with the 3 minus. Okay. More examples, calcium chlorate. So look at the table for the chlorate. For the chlorate part, the chlorate is the ClO3 minus. So that is the ClO3, and that is a negative. This one is 2 plus, right? This one is negative in there. So here you go. So I'm just going to go ahead and crisscross those charges. So my formula is going to be Ca. And the reason why I put parentheses around the ClO3 because now this is going to become 2 like that. Okay. Calcium phosphate. So you do have calcium, which is 2 plus, and the phosphorus in there, which is a 3 minus. You can crisscross those charges in there. So now the calcium is going to be 3, And the phosphate, again, put it in parentheses, and that is going to be 2. Look, if you don't put the parentheses, then that is very confused. You're going to be confused because this 2, it belongs to the phosphorus and the oxygen as well. As I said, 2 atoms of phosphorus and 2 times 4, so that is 8 atoms of oxygen. Calcium hydrogen phosphate. So all of those you can find them. The hydrogen phosphate, this is hydrogen phosphate. So this is hydrogen phosphate here. It's HPO4 2 minus. So that is going to be the calcium. The calcium is 2 plus, group number 2. The hydrogen phosphate from the table is -1. So we're going to go ahead and cross the charges, and the calcium will have coefficient 1 and the hydrogen phosphate will have coefficient 2. Magnesium phosphate, same thing. I do have the magnesium in there. This is 2 plus. The phosphate is the PO4 3 minus. So we're going to go ahead and cross those charges out, and we're going to have magnesium 3 and the PO4 that is going to be 2. For nonmetals, for cases when you have 2 nonmetals that are bonded with each other, or if you have a metalloid that is bonded to a nonmetal. All of these are metalloid. These are between metals and nonmetals. They do have a characteristics between metals and nonmetals. So boron, silicon, germanium, arsenic, antimony, tellurium, and astatine. All of those are metalloids. So these also, whatever the rules we're going to go over, they are applicable for them as well. So here you have 2 nonmetals. You don't have a metal. In this case, there is no metal, okay? So there's no metal, you cannot consider the charges. So please do not consider the charges at all. We have to use prefixes instead. So we're going to name the first nonmetal, then we're going to name the second one, and we're going to use the prefixes. These are the prefixes in there. You don't have to memorize those prefixes. You can write them on a piece of paper. It's fine by me. So 1 stands for mono, di stands for 2, tri stands for 3, tetra stands for 4, penta stands for 5, hexa 6, hepta, octa, nona, and deca. Okay? And then you're going to change the ending of the second nonmetal into ID. So let's have an example in there. Let's have an example. You never calculate the charges, as I said, because these are 2 nonmetals in there. So never calculate the charges. So let's see. This is going to be N and oxygen. We're going to use the prefixes, remember. So you're not going to calculate the charges. You're just going to use the prefixes. And these are the prefixes in there. So how many nitrogens do I have? 2. So it's going to be dinitrogen. So that's going to be a dinitrogen. And then how many oxygens? 4. So it's going to be a tetra oxygen. So tetra, it's going to be a tetra. And then oxygen, we know that the ending is going to be ox. And then I add an IDE. So it's going to be oxide. So it's going to be tetra oxide. So always oxygen, okay, always oxygen is ended to be an ox, and then add an IDE at the end. So it's going to be oxide. This is the same thing. So the CO in there, CO is 1. So whenever you are starting with the first nonmetal to be just 1 atom, you don't have to say mono. But if the second nonmetal is 1 atom, you have to say mono. Okay? So we're going to drop the mono from the carbon there, and we're just going to say carbon. It doesn't sound right if you say monocarbon monoxide. See, it's just like carbon. So carbon means that it's like 1 carbon. You have 1 carbon, and then you have the mono oxide. Okay. There is a space between the dinitrogen and the tetraoxide. The tetraoxide is just 1 word. Same thing, you have a carbon and then a space and then the monoxide. This one is going to be boron. 3 chlorine, so it's going to be a trichloride. Okay, this is the case of 2 nonmetals because boron is a nonmetal. Boron is actually, it's not an, it's between a metal and a non-metal. So boron is considered to be a metalloid. So boron is a metalloid, and it is not a metal. So pay attention. Here it's the cases of two non-metals, or a metalloid, or and a non-metal. So it's going to be boron, trichloride. This is why I'm using the prefixes. This one is going to be nitrogen. Don't use mononitrogen if you have one atom at the beginning of the compound. So this is going to be nitrogen. It's going to be trichloride. Here I have 4 phosphorus, so I have to use the prefix for the 4, right? 4 stands for tetra, so it's going to be tetra phosphorus. Okay, it's going to be tetraphosphorus. And 6 stands for hexa, so it's going to be hexa oxide. Okay, it's going to be hexa oxide. So tetraphosphorus hexa oxide. Guys, hexa and oxide, these are one word. There is a space between the tetraphosphorus and the hexa oxide. This is a disulfur. It's a difluoride. So disulfur, difluoride. See, you don't calculate the charges at all. This means that if I'm given the name, it's easy to go ahead and draw the formula in there by simply following up the prefixes. So here I have 2 sulfurs, I have 2 fluorines. Okay, this one is going to be a selenium, and it is going to be a dioxide. Let's say if you say selenium oxide is SeO. It is not SeO2. So you can see that the prefixes that you are putting are very important to determine the right structure. If you skip those prefixes, your structure is going to be wrong. This is nitrogen dioxide. And I'm sure you all know the CO2 is carbon dioxide. This is why it's named carbon dioxide in there. It's carbon dioxide. Okay? So when given the name, you want to get the formula. Never, ever, ever calculate the charge. Just write it as it is named. So phosphorus pentachloride. Penta starts for 5, right? So that is going to be phosphorus is the P. And the pentachloride, you do have 5 fluorines. Sulfur hexafluoride, this is a sulfur, and you do have 6 fluorines. Okay? I write it as SF6, not S6F. S6F means I have 6 sulfurs, and I don't have 6 sulfurs in here. It's just 1. So just pay attention to that.